Here we have two functions of f of x, both of them are linear. The one on the left, f of x, is increasing and the slope is positive, and the one on the right, f of x, is decreasing and the slope is negative. This is very important for the following steps. Here I want to determine the relationship between the function f of x and its derivative f prime of x. So notice this. The blue graph is the function f of x. Now I'm going to split that into two segments, left and right. On the left segment, f of x is increasing, and then on the right side, f of x is decreasing. Now to determine the behavior of f prime of x, I'm going to draw tangent lines, since the slope of this tangent line gonna be the behavior of the derivative. Here the slope is positive, which means the derivative gonna be positive, and then here slope gonna be negative, which means the derivative gonna be also negative. Therefore, when f of x is increasing, f prime of x is positive, and then when f of x is decreasing, f prime of x is negative. This is also the other way around. So if f prime of x is positive, that means f of x is increasing. Now in case of concavity, note here on the first graph, f of x concave down, and then on the second one, f of x concave up. Now I want to see the behavior of the function f prime of x through this curve. So I'm going to draw this tangent line through the curve. Notice the tangent line in the middle. F prime is 0 since the slope is horizontal. On the left, f prime is positive since the slope is positive. And then on the right, the slope there is negative, therefore the derivative gonna be negative there. So in this graph, as we move from left to right, f prime of x is decreasing. Now in case of f of x concave up, I'm gonna do the same thing. So I'm gonna draw this tangent line through the curve to determine the behavior of the derivative. Starting from the left, the slope there is negative, therefore the derivative is negative. And then in the middle, slope is horizontal, so the derivative is 0. Then on the right side, slope is positive, therefore the derivative is positive. So as we move from left to right, here f prime of x is increasing. Therefore, when f of x concave up, f prime of x increasing, and then when f of x concave down, f prime of x is decreasing. It's also the other way around. So if f prime of x is increasing, this means the antiderivative f of x concave up. Now, between f of x is increasing and then decreasing, we're gonna have a critical point, and this critical point gonna be a local maximum or minimum. And then between concavity of the function, we're gonna have an inflection point.